Okay, let's unpack this. If you have ever, and I mean ever, tried to use a customer service chatbot, you know the pain.
Oh,
You
yes.
know that feeling, right? You ask a simple question, and the second it doesn't fit the script, you just hit this digital wall.
Right. It feels like you're talking to a menu,
Yeah,
not a helper.
exactly. A very rigid menu. And heaven forbid you need to refer to something you said, 2 sentences ago. It's just gone.
Instantly.
That experience, it leaves you feeling completely unheard. And I have to imagine for businesses, it's just a huge drain on goodwill.
It is. And that experience is the perfect place for us to start because it really sets the stage for our mission today.
Okay.
We're going to do a deep dive into how we move past that, how we build truly advanced conversational AI systems. And our blueprint for this is Chapter 5 of our source material, which is all about using the Spring AI framework to do it.
So we're building the solution.
We're building the solution. The goal here is to really understand the tech that lets us move beyond those rigid, frustrating bots to experiences that are genuinely intelligent, that are context-aware, and that are, actually satisfying to use.
So we're not just complaining about bad bots today, we're actually laying out the blueprint for how to build great ones.
Exactly.
We're going to unpack why those simple systems fail and then reveal the 5 key advancements that really make modern conversational AI a generational leap forward. We're talking about the ability for these things to reason, to remember.
Precisely. And we'll get into the weeds on the technical stack needed to do this, all using Spring AI as that backbone for, Java developers. We're going to detail how you manage chat history, which is a surprisingly tricky problem, and then we'll get into the really advanced stuff.
Like the human-like reasoning.
Exactly. Techniques like chain of thought or CoT, and the really powerful ReaCT prompting framework. So if you're listening, you are going to walk away understanding not just what these systems say, but how they actually think and decide what to do next.
Okay, let's unpack this. So let's start by defining the battlefield here. Let's talk about the specific failures of those basic rule-based chatbots. When we say rule-based, we mean the old-school decision tree models, right?
The ones that are all about keywords and predefined flows. And the source material really nails this. It outlines 4 fundamental failings of that old tech.
What's the first one?
The first, and maybe the most crippling, is their complete struggle to comprehend context.
Right, the memory problem we just mentioned.
Exactly. A traditional chatbot is stateless. Just imagine trying to have a conversation where you forget everything that was just said. That's what's happening. Each response is based only on the immediate thing you typed.
So follow-up questions are basically impossible.
They're impossible unless a developer specifically predicted that exact conversational path and hard-coded it, which almost never happens in the real world.
And I guess that leads right into the second limitation, which is their inability to handle anything complex.
A profound inability, yes. If a user has a problem that needs, say, information from 3 different places or needs to access external data, the simple bot just breaks. It completely falls apart.
It's designed for what are your store hours, not my order from 3 weeks ago arrived damaged. What are my options based on my warranty?
Precisely. It's built for simple transactional Q&A, not layered problem solving.
And the result of that is inevitably the third point, which is just those rigid, frustrating responses.
You get stuck in a loop. When the bot can't find a keyword, you get that dreaded, "I'm sorry, I don't understand that," or "Please rephrase your question."
Yes. Which just makes you want to type "speak to a human" in all caps.
Exactly. And it leads to terrible user dissatisfaction because there's no nuance.
And that's the final point, right? The complete lack of nuanced dialogue.
It is. They have no idea what sentiment is. They can't detect tone. If you're clearly frustrated or angry, the bot just plows ahead with its cheerful, pre-programmed script.
Which just makes everything 10 times worse.
It accelerates the frustration. So that's the old way.
Yeah.
But conversational AI, the kind powered by LLMs and frameworks like Spring AI, it just changes the entire game. It addresses all 4 of those limitations directly.
Okay, so the source identifies 5 pillars of advancement that define this new way. Let's break those down.
Absolutely. The first pillar is the most fundamental. Contextual understanding.
The memory.
The memory. It's the ability to grasp linguistic nuance, to maintain the thread of a conversation, and ensure coherence across the entire dialogue, not just turn by turn. This means the AI can handle pronouns, follow-ups, everything seamlessly.
So it's no longer a stateless machine, it's a stateful conversational partner. That's a huge shift. What's number 2?
Number 2 is adaptive learning. These advanced systems aren't static. They aren't just a config file sitting on a server. They actually improve over time.
How so?
They can learn directly from user interactions. They see what works, what doesn't, and they refine their understanding and their responses. It means the system gets smarter on its own, adapting to new products or new ways people talk.
Okay, and that leads into the third pillar, which you mentioned, the tone mismatch. This is emotional intelligence.
It is.
Now, I have to push back a little here. Emotional intelligence in an AI, that sounds a bit like a buzzword. Is it really feeling emotion, or is it just, fancy sentiment analysis?
That's a very fair challenge. And you're right. At this stage, it's primarily very, very sophisticated sentiment analysis that's applied dynamically.
Okay.
It's the system's ability to accurately detect if you're angry or happy or neutral and the intensity of that feeling.
Yeah.
And then it uses that to choose a more empathetic and appropriate response strategy
So if it detects anger, it can switch to a de-escalation script.
instantly.
Yeah.
It pivots. It will use phrases that acknowledge the frustration instead of just ignoring it. So the intelligence isn't in the feeling, it's in the action it takes based on the sentiment it detects.
I like that framing. It's actionable empathy. Okay, what's pillar 4?
Pillar 4 is the real hallmark of these advanced systems, multi-turn dialogue. This is the ability to engage in complex, multi-step conversations.
So we're moving way beyond simple Q&A.
Way beyond. Think about guiding a user through a 10-step troubleshooting process with multiple branches, or filling out a complex application form just by talking to the AI. That's multi-turn dialogue.
And the fifth and final pillar brings it all together.
Personalization. By looking at user data, past conversations, and your preferences, the system can tailor the entire experience. It's not just a generic helper anymore, it's your assistant. It knows how you like to solve problems.
And this is where Spring AI comes in. It's the tool that lets developers actually build all of this.
It's the technical enabler. It provides a robust, idiomatic Java framework to build these systems. It basically acts as an abstraction layer,
Meaning?
meaning a Java developer can interact with powerful LLMs, OpenAI, Azure, whoever, without having to wrestle with all the different complex APIs for each model. Spring AI handles that. And crucially, it lets you implement these advanced techniques like chain of thought prompting, which we'll get to make the AI mimic a human thought process. It lets the developers focus on the logic, not the low-level plumbing.
Okay, so we've set the stage. We know the old way is bad, the new way is good. If Spring AI is the architecture, then prompting. Prompting is the language you use to control what the AI does inside that architecture.
That's a perfect analogy. Prompting is everything. It's the navigation system for the AI.
Yeah.
And we're talking about something way beyond just, typing text into a box.
Right.
The design, the structure, the exact phrasing of your prompt. It has a massive influence on the quality and the format of the AI's response.
Oh.
Mastering prompting is it's essential for anyone building these things.
So let's get into the different types of prompts. The source material lays out a kind of taxonomy here. Where do we start?
We start with the most straightforward one, direct prompting. This is exactly what it sounds like. You ask a clear, specific question, or you give an unambiguous instruction.
No room for interpretation.
None. The goal is to keep tight control. A classic example is a support bot asking, "Can you please describe the specific issue you're facing with your product's login?"
Right, that forces the user to provide a specific piece of information. It's great for things like support tickets or processing an order where you need clear data points. It cuts down on the ambiguity.
Exactly. And the contrast to that is indirect prompting.
So this is much softer.
Much softer. It's more subtle. You're encouraging the user to share information without asking them a direct question. This is all about building rapport or getting more qualitative feedback.
Give me an example.
Instead of asking, rate our product from 1 to 5, an indirect prompt might be, tell us about your recent experience with our delivery service. It invites a story, not a number.
And that leads to the split between open and closed input. So open-ended prompting is designed to get those detailed, descriptive answers, the stories.
Exactly. It's asking for narrative and context. It's what you use for brainstorming sessions or when you're gathering initial feedback and you don't even know what all the possible issues are yet. The prompt is broad, like describe the functionality you wish our application had.
And on the flip side of that coin is closed-ended prompting.
Right. This is for speed and efficiency. You're asking questions that can be answered with a yes, a no, or from a very limited set of choices.
Like, did you receive the confirmation email? Yes or no?
Perfect example. The use case is super clear. Things like lead qualification, are you based in the US? Or quick confirmations to make sure a process is on track.
Okay, so those are about how you frame the initial question. But what about prompts you use during the conversation to keep it flowing?
Right. This is where that memory we talked about becomes critical. The first type here is contextual prompting.
This is where the AI really starts to feel smart.
It is. This is where it uses the previous conversation history, the context, to make sense of the new input. So if you were just talking about a specific bike model and the user then asks, what about that item? A good system knows that item refers to the bike.
It doesn't ask what item.
It doesn't. It just answers the question. And then there's clarification prompting, which is almost the opposite. This is the AI admitting it's confused.
Which is actually a great feature. It's like the AI raising its hand and saying, hang on, I'm not sure what you mean.
It's a critical safety feature. When the system detects ambiguity, maybe a word has two meanings, it asks for clarification. Something like, I didn't quite get that. Are you asking about our return policy or our exchange policy?
And that stops the conversation from going completely off the rails.
Instantly. It resolves the ambiguity before it generates a wrong and potentially disastrous answer.
Okay, before we dive into how we build that history, let's just touch on the more advanced foundational types, the ones that really leverage the LLM's own knowledge.
Good idea. This is the key transition. The first one is zero-shot prompting.
Zero shot.
It means you're asking the AI to do a task without giving it any examples of that task in the prompt. You're relying purely on its pre-trained general knowledge.
So like asking it to explain quantum computing in one paragraph, you're just assuming it knows.
Exactly. You provide no examples, just the instruction.
Mm-hmm.
And the counterpoint to that is in-context learning, which is more often called few-shot prompting.
So here you do give it examples.
You do. You provide a few 2 or 3 shots right inside the prompt itself to show it exactly what you want. So if you wanted to summarize an article in a witty, sarcastic style, you'd give it 2 examples of witty, sarcastic summaries first.
And then you give it the new article.
Right. And it uses those examples to nail the specific tone, style, and format you're looking for. It dramatically improves the quality for specific nuanced tasks. Which brings us right back to that fundamental flaw in any simple implementation. The lack of memory, the lack of state.
Right.
So when you first start building a conversational app with Spring AI, maybe with a Node.js front end talking to the back end, the key thing you realize immediately is that the basic chat client is stateless. It does not support conversational history out of the box.
So there it is, the stateless problem. Every single request is treated like it's the very first one. If a user asks about a price and then asks, does it come in blue? The AI has no idea what it is.
None at all. Unless you explicitly build that memory in, the system is just a simple request-response machine, which is why we have to move beyond that to get those useful multi-turn dialogues we were talking about.
So the goal is obvious. We need to implement a system that maintains a history to provide context. But I have to ask the big developer question here.
Go for it.
If the front end has to send the entire chat history back to the Spring AI backend with every single request, isn't that going to be incredibly slow and ridiculously expensive? I'm just thinking about token usage.
That is the single most critical question for any engineer working with LLMs, the cost of context. You've hit it exactly.
So what's the solution?
The solution is really about careful implementation focused on 2 key areas, session management and, crucially, context pruning.
Okay, let's start with session management. How do you handle that with the Spring AI components?
Well, you have to make changes on both ends. In the source architecture, they talk about QAHisController.java and QAHisService.java. The Node.js front end has to be updated to hold on to that running history, maybe linked to a session ID. And then it passes that whole history object back with every new query.
And how does Spring AI on the back end make sense of that history?
It uses its standardized message object structure, everything. The initial system instruction, every user query, every AI response is wrapped in a message object. And these messages have roles: system, user, and assistant.
Okay, so the system message is like, you are a helpful bike assistant, the user is me, and assistant is the AI's previous replies.
Exactly. So on the back-end service, the QA service, its job is to take that raw history, rebuild it into a properly ordered list of those message objects, and then add the user's new message to the end of that list.
In that entire list, user 1, assistant 1, user 2, assistant 2. That whole thing gets sent to the LLM.
That whole thing gets passed to the chat client. The LLM sees the full transcript leading up to the current question. That's how it maintains coherence.
Okay, but that brings us right back to my question about cost and tokens. If a chat has 50 turns, that payload is going to be enormous.
It will be. And that's where context pruning comes in. You can't just send the history forever. You'll hit the model's context window limit, and the cost will skyrocket.
So how do developers usually handle that pruning?
The logic for this lives in your application service layer, so in the QA HIST service. The simplest way is just to set a hard limit. You could say, I'm only ever going to send the last 10 turns of the conversation. You just drop the oldest messages.
That seems a bit crude, though. You might lose important context from the beginning of the chat.
You might, which is why a more sophisticated technique is to use the LLM itself to summarize the conversation periodically.
Ah, so you'd send the oldest, say, 30 messages to the LLM with a separate prompt that says, summarize this discussion.
Precisely. And that summary, which is much shorter and uses fewer tokens, then replaces those 30 messages in your history. You're effectively compressing the memory. Managing this trade-off between context and cost is absolutely essential. Without it, your application will not scale.
Okay, so now our AI has a memory. Let's talk about giving it a structured way to think. Let's move on to chain of thought, or COT prompting. This is where it starts to feel a lot more like human reasoning.
COT is a huge leap.
Yeah.
It's transformative. Instead of the AI just jumping straight to a final answer, you explicitly instruct it to break down the problem into smaller, logical steps first.
So it has to show its work.
It has to show its work. It makes its entire reasoning process transparent.
I love this because it's exactly what I do when I'm faced with a tricky problem. I stop, I grab a notepad, and I write out the steps before I try to solve it. COT makes the AI do that same internal planning.
Right. And the response you get isn't just an answer. It's an answer that's backed up by a verifiable step-by-step process that makes it so much more valuable and trustworthy.
And this has some major benefits. The first is obviously improved accuracy and relevance. But you also mentioned it reduces hallucination. How does showing the steps stop the AI from just making stuff up?
Because it forces a kind of internal verification. When an LLM tries to give a complex answer in one shot, it can easily skip logical steps or dependencies.
Okay.
By forcing it to write out Step 1, determine the user's location. Step 2, check stock levels in that location. It has to make sure those steps are logically coherent. It's almost like it's peer-reviewing its own logic in real time, which cuts down on it inserting fabricated facts.
That makes a lot of sense, and it dramatically improves its problem-solving capabilities. It can tackle things that would completely break a normal bot.
Oh, absolutely. It can build you a comprehensive step-by-step troubleshooting guide or a multi-factor financial plan because it's breaking the big problem down into these manageable little pieces.
And it also leads to increased contextual awareness and adaptability. The thinking process itself is adaptable.
It is. The underlying logical structure can be applied to almost any domain, whether you're analyzing legal documents, doing tech support, or tutoring a student.
Let's make this really concrete with some of the examples from the source.
Yeah.
How would CoCon work in a technical support chat?
Okay, so a user says something vague like, my app isn't saving files since I updated my OS. That has a lot of possible causes.
Right.
A co-powered bot would start a methodical process. Its internal chain of thought might be 1. Identify the OS. 2. Check if the app version is compatible. 3. Check file permissions. 4. Check disk space. It would guide the user through each step sequentially, asking for confirmation before moving to the next one. No guessing.
And the financial advice example is even more powerful because it's dealing with sensitive, interconnected data.
It is. CalOT is perfect for that. A user asks how to maximize their 401k. The AI's chain of thought would be, Thought 1, find out their current contribution rate. Thought 2, assess their risk tolerance. Thought 3, compare their investments to that tolerance. Only after it's gone through all those steps does it formulate a final recommendation. The whole thing is transparent and logical.
And the actual implementation in Spring AI, it sounds almost too simple. The source says you just modify the service, the QACOutService.java, and add an instruction like, please provide your chain of thought.
That's the deceptive part. Yes, that single instruction is the key prompt engineering trick. That's what triggers the LLM's reasoning mode. But the real complexity then shifts to your application.
What do you mean? The LLM sends back this big block of text with all the steps and the final answer mixed together.
Exactly. You can't just display that to the user. It would be a mess.
So as the developer in my QA site service, I have to parse that response.
You have to build a robust parser. You're looking for specific markers, like step 1, thought, or final answer. You need to use string processing or regular expressions to pull out the reasoning chain and separate it from the concise final answer that you actually show the user.
So you can display the steps if the user wants to see them, but you present the clean answer up front.
Precisely. Spring AI gives you the raw, structured output, but it's your Java code that turns it into a clean, usable experience. So if chain of thought is about creating transparent internal reasoning, ReaCT, which stands for reason and act, is about connecting that reasoning to external actions.
Okay, so this is where the AI stops just talking and starts doing things.
That's exactly it. ReaCT is a sophisticated methodology that combines that internal planning, the reason part, with action-oriented prompts, that act part. It's designed for complex tasks that require interacting with external tools, APIs, or databases.
This sounds much less like a chatbot and more like a true operational agent.
That's the perfect term for it, an agent. The whole process is built on a loop. First, the AI reasons about what it needs to do. That's its thought. Second, it decides on an action, like calling an external tool. Third, it receives an observation, which is the result from that tool call.
And then it loops back. It uses that new observation to reason about its next step.
It does. It's a continuous cycle. The AI isn't just retrieving data, it's dynamically figuring out what data it needs, how to get it, and then what to do with it once it has it.
So there are two key components here. The retrieval component, which could be a vector database to find information quickly, and the generative component, which is the LLM itself, putting it all together.
Right. And what makes this work so well in the Spring AI ecosystem is the tool and function calling mechanism.
Tell me about that.
As a developer, you can define regular Java functions or tools, and you register them with the chat client. When the LLM gets a ReaCT prompt, it knows what tools are available.
So its reason step is basically it deciding which of my Java functions it needs to call.
Exactly. The LLM will then generate a special, structured output that says, I need to perform an action. Call the Get Customer Account Details tool with this customer ID.
And Spring AI handles that. I don't have to parse some weird text output to figure out what it wants to do.
Correct. Spring AI translates that structured request from the LLM into an actual executable Java method call in your application. Your code then runs the function, hits a database, calls an API, whatever, and the result of that function is the observation.
And that observation gets automatically fed back into the AI's context for the next loop.
Automatically. So the AI can continue its reasoning with fresh, accurate, real-world data.
The benefits here seem huge for developers, the main one being enhanced accuracy and transparency. The whole thought, action, observation structure seems much easier to trace and debug than a simple QT.
It is. That audit trail is vital for production systems, especially when the AI is making important operational decisions, and its practical use is enormous. In customer support, it could look up an order status and initiate a refund. In technical Q&A, it could query an internal knowledge base and diagnose a system error.
Let's walk through the AI bike assistant example from the source. That really makes it clear. The user asks, can Hyperdrive Turbo X1 be used in the city? Also use tags with other info.
Okay, so the key here is that the prompt for this service, the characterized service.java, explicitly tells the AI it has tools available and that it must structure its thinking using those labels: thought, action, observation, and conclusion.
So what's the first thing it does, assuming it has a tool like product lookup?
Right. The process starts with its internal plan. Thought 1. I need to figure out if this bike is good for the city. I need to check its product tags.
Okay, that thought triggers an action.
Action 1. Call the tool product lookup with the arguments, Hyperdrive Turbo X1 and tags.
The Java application runs that, gets the tags from a database, and returns them.
And that becomes the observation. Observation 1. The tags for this product are bicycle and city bike.
Okay, so question 1 is answered, but the user also asked for other info, so the loop has to continue.
It does. The LLM gets that observation and it updates its plan. Thought 2. Okay, I've confirmed it's a city bike. Now I need to get other relevant info, like its features.
Which triggers another action.
Action 2. Call product lookup again, but this time ask for features.
And your app returns the feature list.
And that's observation 2. The features include a powerful motor, wide tires, integrated lights, and so on.
So now, after 2 distinct tool calls, the AI has all the information it needs.
And it synthesizes all of it into the final conclusion. Yes, the Hyperdrive Turbo X1 is a city bike. Its key features, like the motor and integrated lights, make it highly suitable for urban environments.
It's not just an answer. It's a conclusion based on externally verified data with a full audit trail of how it got there. That's incredibly powerful.
It completely transforms the AI from an information retriever into a problem-solving engine.
But I have to ask, again, from the developer's side, managing that whole loop, handling failures if an external API is down, That seems like it could get really complex. Does Spring AI help with that?
That is a crucial production concern. Spring AI abstracts away the hardest part, which is the communication and parsing. By letting you define your tools as standard Java methods with annotations, the framework handles turning the LLM's request into a method call and sending the result back.
So I can just focus on the business logic of my tool, like how to query my database, and not on parsing the AI's intent.
Exactly. It significantly reduces the friction of building these complex agent-based systems. You're still in charge of the loop logic, but the plumbing is handled for you.
That level of orchestration and planning is it's amazing. And the fact that it's all manageable within a standard Java ecosystem is the real key here for our audience. Wow. We have really covered the entire journey here. We started with those rigid, frustrating, stateless
The
chatbots,
ones we all know and hate.
and we've made it all the way to these sophisticated conversational AI agents. We've seen how Spring AI gives Java developers the tools to build in memory, to enable human-like reasoning with chain of thought, and then to take action with ReaCT.
I think what's so fascinating is how Spring AI gives you this abstract but very precise control over what the model is doing. By managing history, by structuring your prompts for CoT and ReaCT, you move your application from just answering questions to actually planning, acting on external data, and analyzing results.
It's no longer a black box.
Not at all. You're building systems that can proactively solve complex enterprise-level problems.
The ability to demand a chain of thought for a logical process or to structure a ReaCT sequence for a real-world action, it turns the app from a text generator into a transparent, auditable decision-making system. The complexity of the problem isn't a blocker anymore. It just defines the structure of the AI's approach.
The concepts in this deep dive are really pivotal for anyone looking to build serious, reliable enterprise apps with LLMs, but without losing control or, going broke from token costs because of poorly managed context.
So think about this. Consider how leveraging these advanced prompting methods for navigating complex internal policies and ReaCT for pulling live data and taking action could turn a single conversational interface into the operational brain for your entire enterprise. A brain capable of solving multi-layered problems. So if you're a Spring developer, what stands out to you as the first truly complex multi-layered dialogue or action sequence you'll try to tackle with the power of ReaCT and the tool mechanism?